So in this video, let's look at a general strategy for graphing rational functions. To graph a rational function, f of x equals p of x over q of x, where p of x and q of x have no common factor other than constants. 1. Find any real zeros of the denominator, determine the domain of the function, and sketch any vertical asymptotes. So what we're really doing here in terms of a graphing strategy is we're finding any vertical asymptotes, and we do that by finding the zeros of the denominator. 2. Find the horizontal asymptote or the oblique asymptote if there is one, and sketch it. So remember, we'll either have a horizontal asymptote or an oblique asymptote. We'll only have one or the other, and there'll only be one of one or one of the other, or there will not be any. 3. Find any zeros of the function. The zeros are found by determining the zeros of the numerator. These are the first coordinates of the x-intercepts of the graph. So we found vertical asymptotes, we found horizontal or oblique asymptotes. Now we're finding the x-intercept. And the way that we can do that is by setting the numerator equal to 0. 4. Find f of 0. This gives us the y-intercept, which will be the point 0 f of 0 of the function. So now we found the y-intercept. And 5, we're going to find other function values to determine the general shape, then draw the graph. So this is going to be our general strategy for graphing rational functions. Let's look at an example. So in this example, we want to graph the rational function f of x equals 3x minus 2 over 2x squared plus x minus 1. We're going to find and label all asymptotes, the x-intercepts and y-intercepts, and then we're going to state the domain as well. So let me start by rewriting our function here. So we have 3x minus 2 over 2x squared plus x minus 1. And I want to begin to make sure that we don't have any common factors that can be divided out because that affects our rules, if you'll remember. So the numerator can't factor. That's going to just stay 3x minus 2. But the denominator can factor, and that's going to factor into 2x minus 1 times x plus 1. And just to verify that, 2x times x will be 2x squared. The outers, 2x times 1 would be 2x. The inners, minus 1 times x is minus x, and 2x minus x is going to give us x. Minus 1 times 1 is minus 1. So the denominator factors into 2x minus 1 times x plus 1. Now, we can use this to find vertical asymptotes. So the vertical asymptotes are going to be where the denominator equals 0. So 2x minus 1 times x plus 1 equals 0. And if I solve that, then 2x minus 1 equals 0, or x plus 1 equals 0 by the zero product principle. If 2x minus 1 equals 0, then x is going to equal 1/2. If x plus 1 equals 0, then x is going to equal negative 1. So we have two vertical asymptotes. The vertical line x equals 1/2 is going to be a vertical asymptote, and the vertical line x equals negative 1 is going to be a vertical asymptote. So we've done step 1 of our strategies. Incidentally, 1/2 is the 0 of the denominator, negative 1 is the 0 of the denominator, and if we wanted to state the domain, we could go ahead and do that right now. Our domain is going to be all real numbers as long as x is not negative 1 and x is not 1/2. But x could be anything other than negative 1 and 1/2. Or if we write that in interval notation, that would be negative infinity to negative 1, union negative 1 to 1/2, union 1/2 to infinity. So there is our domain. And again, the negative 1 and the 1/2, which have to be eliminated from the domain, give us our vertical asymptotes. Step 2. We want to find either horizontal or oblique asymptotes. So to determine if we're going to have a horizontal or an oblique asymptote, we look at the degree of the numerator and the degree of the denominator. Well, in this case, the degree of the numerator is 1, the degree of the denominator is 2, so the degree of the numerator is less than the degree of the denominator, so that means we are going to have a horizontal asymptote, and since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is going to be the horizontal line y equals 0, and what that really means is it's the x-axis. There will not be an oblique asymptote, so oblique asymptote, there's none. Step 3, we want to find any zeros of the function. So zeros of the function, again, we can find just by taking the numerator and setting it equal to 0. And just to kind of explain that, if I take 3x minus 2 over 2x squared plus x minus 1, and if I set that equal to 0 in order to find the zeros, the first thing I'm going to do is multiply both sides by the denominator. And so if I multiply both sides by the denominator, that's going to give me 3x minus 2 equals 0, which is just the numerator that equals 0. So there's really no sense in bothering with that first step. It's always just going to be whatever we get when the numerator is set equal to 0. Well, if 3x minus 2 equals 0, then 3x equals 2, and so then x equals 2/3. So we're going to have an x-intercept, and our x-intercept is going to be the point 2/3, 0. So we know we have two vertical asymptotes, we know we have a horizontal asymptote, which is the x-axis, and we know we have an x-intercept, and that x-intercept is the point 2/3, 0. So let's come up here and let's find our y-intercept. So to find the y-intercept, I'm going to find f of 0. So that's going to be 3 times 0 minus 2 over 2 times 0 squared plus 0 minus 1. Well, 3 times 0 is 0, minus 2 is negative 2. 2 times 0 squared, 0, plus 0, 0, minus 1 is negative 1, and negative 2 divided by negative 1 is positive 2. So our y-intercept is the point 0, 2. So at this point, we have found the key features of our rational function. We know the asymptotes, we know the x-intercept, we know the y-intercept. So let's plot those, and then we'll see if we need any other points to determine the general shape. So here I have a rectangular coordinate system, and so I'm just going to find my asymptotes and my intercepts. So I know that I have a vertical asymptote at negative 1. So if there's negative 1, then positive 1 would be here, which means 1/2 would be here. And so I know I have a vertical asymptote at negative 1. I have another vertical asymptote at 1/2. So x equals negative 1 and x equals 1/2. Those are asymptotes. I know that the line y equals 0 is a horizontal asymptote. So I'm going to just kind of draw a dotted line through the axis. Can't really see that very well, but I do have a horizontal asymptote there. I know the x-intercept is the point 2/3, 0, which is going to be maybe around right there, a little bit to the right of 1/2, but not quite to the 1. So that is the point 2/3, 0. That's a x-intercept. And I know I have a y-intercept at 0, 2. So there is a y-intercept at, again, that is 0, 2. So that's all I know about the graph at the moment. So I need to find maybe some other points to kind of get a general idea of what this curve is going to look like. So let's start by maybe finding another point or two to the left of -1. And so I can just find some values, maybe make a table of values. And again, my function is f of x equals 3x minus 2 over 2x squared plus x minus 1. So if I choose a value to the left of x equals -1, so maybe I'll let x be -2, then I'm going to find f of -2. And I'm going to just do that down here. So f of -2 would be 3 times -2 minus 2 over 2 times -2 squared plus -2 minus 1. 3 times -2 will be -6, minus 2 will be -8 on top. On the bottom, -2 squared is 4, times 2 is 8. 8 plus -2 is 6, and 6 minus 1 is 5. So I have -8/5. So if here is -1 and here is -2, -8/5 is the same as -1 3/5. So here's -2, -1 3/5 would be like here. And maybe I'll find one other point over here. Maybe we'll find, what if we get -3? Let me write down my -8/5 there, so -3. So if I find f of -3, that's going to be 3 times -3 minus 2 over 2 times -3 squared plus -3 minus 1. So 3 times -3 is -9, minus 2 is -11. -3 squared is 9, times 2 is 18. 18 plus -3 is 15, and 15 minus 1 is 14. So I get -11/14. So -11/14 is going to be just a little bit above -1, so somewhere around there. So this graph should be getting asymptotic over here as we go this way to the x-axis. It's going to go through this point, it's going to go through this point, and it's going to curve and get asymptotic there to the line x equals -1. So over here it's going to look something like this. In between, I know it's crossing through this point, but what I don't know is it's possible that it could be like coming down, going through that point and going back up. Asymptotic here, coming and going back up. It could be coming down, going and going like this, or it could be coming up and coming back down, or it could be coming up and going up. I don't know. So I'm going to have to find a few points to figure that out. So I'm going to substitute in a value between, let's say, 0 and -1. So maybe -1/3. Yeah, let's do -1/3. So f of -1/3. So if I substitute in -1/3, I'm going to have 3 times -1/3 minus 2 in the numerator. And I'm going to have 2 times -1/3 squared plus -1/3 minus 1 in the denominator. Well, 3 times -1/3 will be -1, minus 2 will be -3 in the numerator. In the denominator, -1/3 squared will be 1/9, times 2 is going to be 2/9. So I have 2/9 plus -1/3. -1/3 will be -3/9, minus 1 will be 9/9. So 2/9 minus 3/9 is -1/9, minus 9/9 is -10/9. And so that's going to be -3 times -9/10. And that's going to be positive 27/10, so about 2.7. So at -1/3, we're going to be up at 27/10. So like if here's 3, we're going to be up here. So that makes me convinced that it's coming like this. Now the question is, does it turn around and go back up, or does it keep going down? So I need to plug in a value maybe like 1/4. So I'm going to have to move over here to the side a little bit. F of 1/4. So that's going to be 3 times 1/4 minus 2 over 2 times 1/4 squared plus 1/4 minus 1. Well, 3 times 1/4 is 3/4 minus 2, and that is 1/4 squared is 1/16 times 2 would be 1/8 plus 1/4 minus 1. Now, 2 would be the same as 8/4, so I have 3/4 minus 8/4, and I have 1/8 plus 2/8 minus 8/8 if I find common denominator. So that's going to be negative 5/4, and this will be negative 5/8. 1 plus 2 is 3, minus 8 is 5, so negative 5/8. So negative by a negative is going to be positive, so 5/4 times 8/5, that's going to be 2. So we have the point 1/4 2. So 1/4 2 is going to be still here. So what's happening is that graph's going to turn around, it's going to go through there, turn around and go back up and get asymptotic on this side. So last but not least, I need to figure out what's happening over here. So I know I have an x-intercept at 2/3. So I just need to find another point or two maybe on this side. So if I were to plug in, say, 1. So if I find f of 1, that's going to be 3 times 1 minus 2 over 2 times 1 squared plus 1 minus 1. 3 times 1 is 3, minus 2 is 1. 1 squared is 1, times 2 is 2, plus 1 is 3, minus 1 is 2. So at 1 I get 1/2. So that's going to be up here. But this has to get asymptotic. So this is going to have to turn around. It's going to go above. It's going to have to turn around somehow and come back and get asymptotic to this. And then on this side, it's going to get asymptotic like this. So this is what our graph should look like. Now, if I bring in my calculator, just to kind of verify this, I can enter parentheses 3x minus 2, close parentheses, divided by, my denominator is 2x squared plus x minus 1. And if I zoom 6, see if I get a decent looking graph, and we do. So again, I can see that I have this vertical asymptote at x equals -1. I have this vertical asymptote at x equals 1/2, and I have the horizontal asymptote of the x-axis. And so we can see that this graph does look sort of like what we had drawn. So here we have our graph.